Hey builders, welcome to another video covering Retro Reacts. We're looking at old This Is My Architecture videos from AWS. In this case, it's 2017 March. We're looking at iRobot and how they handled microservices on AWS.
Welcome to This Is My Architecture. My name is Glenn, and today I'm joined by Ben from iRobot.
Okay, so we have Glenn, who's new from AWS side. We haven't seen him in one of these videos yet. And we've got Ben Kehoe, the Chief Robotics Research Scientist at iRobot. Ben is a very good friend of mine. He's a fellow AWS hero. His specialization right now is in serverless, but really Ben covers the entire gamut. This is gonna be very, very interesting, only because this is from 2017. So a lot of the services that are in play probably are replaced with more specific dedicated services, probably because of Ben. Ben is prolific in his technical writings and analysis of the AWS cloud and has driven a huge amount of improvements into those services from the outside. This is really going to be a great video.
Cool name for a company. What does iRobot do, Ben?
So
we all know what iRobot does, but let's hear Ben explain it.
we make connected robots now that talk to the cloud, and that enables our users to communicate with them. You can tell your Roomba to clean from anywhere in the world. And that also enables us to get analytics that we can use to make our products better.
Right.
iRobot also has some very cool STEM educational initiatives that I'll link to in the description to help everybody learn how to build out robots. And they built it on the Roomba platform, stripped down version. It's super, super cool. So it's more than just vacuums at play here, but at the core, that's obviously what they're known for.
They're collecting a lot of real-time usage data around what the robots are doing, which goes into R&D for the next wave of robots.
Definitely.
Very cool. And so you have a really interesting way that you deploy services within iRobot on the AWS platform. Quite
Okay, so it seems like we're going to start off with microservice deployment. Let's listen in.
complex environment.
Right, so about a year ago, we started to develop this system, and it's completely serverless. We use no
That's why he's a serverless hero.
EC2. We do use about 20 different AWS services, and so deploying and managing that is quite a task.
Yeah.
So 20 AWS services back then. I don't know if they'd shrink that down or not, or just switch those to different services today, but that's not uncommon. Given the breadth of AWS cloud service offerings, I'm finding more and more teams who are regularly using 20 to 30 different services in their solutions. And believe it or not, that's actually simplifying what they used to do because they're offsetting a lot of that work, or they're delegating a lot of that work to AWS, where it's better done so that they can focus on business value.
Sometimes playing on the bleeding edge means you've got to develop a lot of things yourself. Has that been your experience?
Yeah, so when we started, there weren't a lot of good options out there for doing deployment, and so we decided to roll our own tooling.
Now there is. AWS offers a whole suite of IoT services. They hadn't started into that, if I remember correctly, in 2017. Again, going back to Ben's feedback into videos like this, it's probably why they now have like the IoT management services in play.
Right. And so why don't you just run us through the architecture you have here for how you actually build the deployments of your services at iRobot?
Yeah, so it starts with, either on a developer's machine or in a repository, you have a number of services, number them maybe, and in each one you have some Lambda code and an SDK defined, and that SDK is code that would allow other services to access it.
Yep.
You have some CloudFormation snippets defined that say how many of those other 20 services you're using, and then finally a Swagger definition of the part of the API that corresponds to that service.
So on disk in each of these repos, they basically have everything you need to do to stand up this microservice and the infrastructure around and how to interact with it, right? So they've got the code, they've got the CloudFormation, and then they've got that Swagger definition, which is for Open API now, which will allow you to say, like, here are the endpoints, here are the parameters for each of those endpoints, and here's what to expect back.
Okay. And each of these, in terms of how you deploy them to Lambda, what language are you using?
We're using Python across all of them, and that allows us to reduce the effort in making those SDKs.
So the interesting thing here is the language doesn't matter as much as the team's knowledge. So if your team's super comfortable with Python, go with it. If you're better in Go, go with that. If you prefer .NET, go for it. There's a ton of languages supported in Lambda now. Back in the day, not so much. There was just the core. But now with the addition of Lambda layers, you can pretty much work in whatever language you want and have that same native experience. But in 2017, they would have been limited into things like Python, into .NET, I believe Go, Java, but they went with Python, probably based on the experience. We'll see if Ben mentions anything about it.
Okay, so nice lean and mean Lambda functions. Okay, so you've got your assets defined down the bottom. What's the next step that you go through to deployment?
So the next step is packaging each of the Lambda code up. And so the first step for that, if a service has no dependencies, you're just taking the code there, zipping it up, and putting in S3.
Good old zip files. Still a great way to deploy, well, not a great way, still a way to deploy your code into Lambda. Containers as a deployment package, I'm actually coming around on now. That's a new feature this year, but actually much smoother deployment experience than trying to zip it all up, just because of the DSL around containers. How you define a container makes a lot more sense than making sure that you have your zip file in the right level of folders. I always mess that up. I have the wrong parent, and then the Lambda doesn't actually execute properly.
And that allows us to then have a build artifact that we can refer to later. Now, on the other hand, if another service, say, depends on service 1, in addition to the code that we're putting up there, we need the SDK as well. And so we inject that automatically based on.
So I was worried there for a minute that they were doing a little deeper coupling and making sure that or deploying these things in dependencies. But what they're actually doing is they're pulling the software development kit out of that service, because that's what it's there for, so that they have that layer to interact with from the second service.
On dependencies that we define inside the services.
Okay, so now you've got your deployment zip files ready to go, stored in S3. What then happens?
Right, so then you need to get your CloudFormation template together. So for that, we take the CloudFormation as defined in the service, and we provide some syntactical sugar for our developers, so we do some transformations on it already. And while the Lambda functions are defined in there, the location of that S3 wasn't known when they wrote it. It's only known once we put it and package it all together.
And that's a good point, is that they don't know where that key is in the S3 bucket, so they're going to have to update that CloudFormation template, probably with another Lambda.
So then we take that and inject that into these templates, which
so
then end up also in S3.
Back to S3.
So that we can, again, have a build artifact for that.
Right, so by this point.
So the reason why Ben keeps calling out the build artifact is that that's the replicability. Yeah, that's the word, replicability. The ability to replicate these builds over and over again, but also to point back and to know what's changed between them. So having these build artifacts, they'd be relatively small in size, so low cost to keep around, but really handy to retrace your steps in the case of something went wrong.
You now have your defined code packages. You've got a defined template that knows where the code is. So it's really nice. What I like about this architecture is you completely abstracted away kind of the deployment asset from the actual development asset itself.
Right.
So there's no dependency there.
And so we have one of these templates per service, so each one gets one. And then we also have a template that goes across all services. And there's a couple of reasons for this. One is that each of these APIs defines some functionality and some piece of an API gateway, but we don't want to have one API gateway API per service, because then the mobile client would have to access a large number of those.
It's a good point. So if they were standing up for every microservice they had, if they had a whole another Amazon API gateway, it would just be too much. So we'll see. I have a feeling he's going to inject something here, because that's the pattern that they've been using, but let's see how they solve this problem.
So instead, we pull all of those together and merge those into one Swagger file that can make an API gateway.
So what they're doing is they're actually merging them all together to make sure that it is the same, like one universal API instead of multiple pieces. So they package fragments in each of their services, they mush them together to make one holistic API, which gives a better experience for internally for developers, but also for the mobile client. It makes that development piece so much simpler.
That goes across all of these services.
Okay, and you're using AWS API Gateway to actually present that to your mobile users.
Yep.
So as much as we think of these as different services, they're microservices, remember. So realistically, your mental model as a developer, especially if I'm the mobile client developer, I'm thinking of it as just the API that gets me all this stuff back. And if in the back end, each endpoint is implemented by a different service, that's fine. I don't really care about that. It's similar to the relationship with me as a builder in AWS. So this is a very, very clever solution, which no surprise.
And then we also include inter-service resources here for pieces that allow our services to talk to each other.
Okay, so at this point now I've got my individual templates per service, I've got my API definition and defined in template. What happens then?
Then you push the button to deploy it.
I wonder if they have an actual button. It'd be fun.
Simple as that.
As simple as that. And you've got these templates in S3 as build artifacts, so if you need to deploy it later, or know what you have deployed or verify it against that. It's all still there.
Are you using some type of third-party system to manage it, or did you just write your own from scratch?
So when we started,
So the good point here by Glenn. There's a lot of different fragments to manage, and you could kind of lose yourself in this. But I think conceptually, it's really, really simple. So I don't know if you'd have to actually have a lot of heavy lifting here, but let's see what Ben has to say.
there weren't options that we felt met our needs, and so we rolled our own.
Okay.
In the future, I see the serverless tooling becoming better and better.
And it has become better. It's still not great, but it's a lot better, and I'm sure that they can leverage some stuff that's out there. Got a couple ideas, but let's see if there's any lasting points or last few points here.
The third-party tools are probably the future.
So hopefully this can get simplified even further for you. So Ben, what's been the biggest benefit of this architecture to you at iRobot?
So the great
Simplicity, smoothness, the awesome audit trail, tons of stuff here.
thing is that because we're a device company and we're not a cloud application company, we're able to skip all of the infrastructure heavy lifting that would come along with scaling an application to millions of robots, and instead just focus on our business logic.
Excellent.
And that's a huge reason to move further to the right in the shared responsibility model towards that managed or, the serverless design patterns, is that you only want to build stuff that's relevant to your business. You don't want to do that undifferentiated heavy lifting. You don't want to worry about the nuts and bolts that aren't critical to what you're actually trying to achieve.
And thanks for sharing with us how you're using a completely serverless architecture comprised of 20 plus AWS services.
Okay, so think about that. The Ben and the team at iRobot had built this in 2017 completely serverless to power millions of robots. Amazing. The only other team I know regularly delivering engineering on the scale is the team at Lego, as far as a serverless, delivering in a serverless manner. So kudos, and that's why Ben is an AWS serverless hero. He is a prolific writer, as I mentioned, and analyst on all this technical stuff. He's driven a huge amount of innovation into the cloud. Specific to this design, I would imagine it's probably pretty similar today. There's a few things that I think would be better served. Something like the CDK, the Cloud Development Kit from AWS, lets you define objects in code that may actually fit this solution better. So instead of having fragments of CloudFormation, you've got everything defined as a CDK app that then will output CloudFormation. You'll still have your build artifacts and things like that, but it kind of merges the Lambda step and the SDK and the CloudFormation step all together into something that's a little bit smoother, and you could have that Swagger combination of the APIs there to make that a better experience for your developers. It doesn't change the services in play, but it sounds like from services in play, as much as there's 20 different services that are being built with, the actual deployment of these microservices really is just S3, Lambda, and CloudFormation. And that's still going to be the case today if you were designing this, but it may be worth exploring the CDK. It's rapidly maturing. It's a really interesting way of building things out in code programmatically. With this fragmentation approach, it might actually fit very, very smoothly into that concept. But other than that, this is a brilliant way of designing microservices deployment, especially when they're all part of a bigger whole. In this case, the interface that the robots have with the back end. It stood the test of time, and there's very little that would actually change today, just a little bit, as Ben already called out and said, in the future, I hope that tooling is matured. I think the CDK is probably the maturation of that. Without seeing the technical details, I don't know, but that's where it feels like it would be going. And that's really the only improvement I can think of for this absolutely fantastic design. So thanks for following along, builders. We'll see you in the next one.